All right, Happy New Year. Good morning, afternoon, or evening, right? It's the new year. How you guys doing today? We're going to start today with chapter 7. We're going to be talking about rational expressions. And this is a very easy concept, especially if you already know how to deal with fractions. If you can add, subtract, multiply, and divide regular fractions and mixed numbers, if you know how to do that really well, I promise you, these are the same concepts, but now they're just going to throw polynomials as denominators. That's basically it. That's the way I want you to see this. These are just like simplifying fractions, but you're going to have polynomials instead of regular just single terms or numbers. You're going to have polynomials both in the numerator and the denominator. With that being said, the definition, rational expressions, the quotient, remember that's division of two polynomials. Think of rational expressions as ratios, fractions, or quotients of polynomials. Remember polynomials, one term is a monomial, two is binomial, three is trinomial, and then after that it's four-term or five-term or six-term polynomial. Remember the degrees of polynomials, my friends. Degrees are the highest monomial exponent in that polynomial. So in this case, it has an exponent of 2, so it's a second degree or a quadratic polynomial. In this case, trinomial, because it's 3 terms. So you guys all remember polynomials, right? Okay, good stuff. So when we're simplifying, we're going to learn how to simplify these things today. When you're simplifying a polynomial, okay, the goal is to factor as much as you can and then get rid of or cancel out like polynomials that are both on the numerator and the denominator. Now before we get into that, I want to warn you of a few things. A lot of times people will say, oh, Mr. Morrow, this is really easy. You get rid of a 3 and you have a -1, and then you get rid of an x here and then you have a 2. And that is completely wrong. That is not right at all. Let me explain this right now, guys, and remember this always, and anyone else watching in the internet. You cannot cancel out individual pieces of polynomials. You cannot cancel out individual terms of polynomials. You can't cancel this x with that x. You cannot do it. So how does it work then? Well, let's factor this. What times what is -3? Or when added together is +2, gentlemen? +3 and -1. Why? Because 3 times -1 is -3, and 3 minus 1 is 2. I know that was a little slow today, but I know we just got back from break. But let's get our mental gears back in working condition here. So now I have x plus 3 over x minus 1 divided by an x plus 3. Now hopefully this will run my point home. I could not take away an individual x. I could not do that. However, I can take away or cancel out exact polynomials. And by exact, I mean exact. They have to be exact. They can't be off by a decimal or by a negative. They have to be exact. So I have an x plus 3 up here. I can get rid of this x plus 3 down here. This simplifies to become just x minus 1. And that would be your simplified expression. Sir? Okay, could you divide? Yes, you can. In this case, you could have divided from the beginning, but that's going to be a very long process for you. And we're going to get to that. It's called the rational expression theorem. But trust me, let's walk before we run. Okay, right now the goal is to factor the numerator and the denominator. Any common factors we have, boom, you slash out. When do we divide? When you can't factor them out. That's when you start dividing. But we'll get there, I promise. Does that answer your question, my man? Thank you, sir. We good so far, guys? Okay, now, a rational expression, as we just finished seeing, is in simplest form. That means it's reduced all the way. When its numerator and denominator are polynomials that have no common divisors, and I would say this, except for one. Except for one. Because one is always a common the factor of everything. So, how does this work? Okay, just giving you some examples of rational expressions that are in simplest form, and then those that are not. X plus 1 over x minus 1. I have nothing in common there. I cannot cancel out the x's, no. I cannot cancel out the 1's, no. Because I cannot cancel out individual terms of polynomials. And I can't cancel out the whole entire thing. Why? Because they're not identical. This is x plus 1, that's x minus 1. The only common denominator they have, or the only common factor, is 1. Over here, what times what is 2, but when added together is 3? When I factor this out. That's right, 2 and 1. So this is x plus 2, x plus 1. I have this over an x plus 3. Can I cancel anything out? Again, the temptation. Moral, what are you talking about? Get rid of this x and get rid of that x. No, you cannot eliminate or cancel out individual terms from polynomials. So that's why these two are already in simplest form. These guys are not. Let's prove it. I have x over x squared. Well, that becomes 1 over x. Right? Hopefully you guys remember that skill. You subtract the exponents when you're dividing the same base. Here I have 3 times x minus 3 over x minus 3. That's not in simplest form, because I can cancel out this x minus 3 and this x minus 3, leaving me with 3. Done. X squared minus x minus 6 over x squared plus x minus 2. Let's go ahead and factor both of them. See if this is simplified or if it's not. So we're going to go ahead and factor. What times what is negative 6, but when added together is negative 1, y'all? Excellent. There we go. Now they're up. Negative 3 and positive 2. Excellent. Thank you. What times what is negative 2, but when added together is positive 1, gentlemen? Positive 2 and negative 1. Excellent. Thank you. Because 2 times negative 1 is negative 2. 2 minus 1 is 1. Excellent. Now, can I cancel anything out? Yeah, the x plus 2 and the x plus 2. Excellent job, my brother. Because those guys were identical. So the simplified answer now would be x minus 3 over x minus 1. So hopefully you guys see the difference between a simplified rational expression and one that is still yet to be simplified. Whenever you're given trinomials or polynomial, 4-term polynomials, factor it out first. Factor out the denominator and then see if you can cancel things out. And I'm repeating things before I read them. I'm sorry. It's a good year. I'm just excited to be here. You simplify a rational expression by dividing out the common factors in the numerator and the denominator. Factoring the numerator and the denominator will help you find the common factors or the common divisors. Go ahead and factor, 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 and then simplify. You guys with me so far? Pretty easy, right? All right, let's have some fun. Let's simplify these, okay? So we got a factor. We got a factor. Again, temptation, trust me. I know you're like, Mr. Morrow, we got you. Stop repeating it. But no, I'm going to repeat it. Temptation, people are going to go like this. Oh, that's gone. And that is wrong. You cannot eliminate individual terms from polynomials. Please remember that, my brothers. Now, let's factor both of these. All right, you guys tell me. What times what is 10, but when added together is 7? Oh, yeah. Plus 5 plus 2. Excellent. All right, what times what is negative 10, but when added together is negative 3? Negative 5 and? Excellent. Positive 2. Good job, gentlemen. Thank you. What can we eliminate? The x plus 2, because they're identical. The other ones we cannot. So my answer is going to be an x plus 5 over x minus 5. That is my answer, gentlemen. Does that make sense, guys? Promise? All right, let's keep going. Okay, how about here? Wait a second. You can't factor these. No, but we can simplify this. Remember, we're going to factor out the common factors. Just factor them out. Get rid of them. Divide the common factor to both the numerator and denominator. So what's 24 divided by negative 6? First of all, we got a negative 4. Boom. That's gone. That's gone. And there you go. You're left with a negative 4. Okay, I've got x cubed over x squared. Yeah, 3 minus 2 is just x. Thank you very much. Exactly, because you brought it up. 3 minus 2 is x. Excellent. And now I got y squared over y cubed. So I got a y left over. Does that make sense, my brothers? Boom, done. Simplified. There's nothing else I can factor out. There is no common factor to y and negative 4x other than 1. Okay, number 3. Again, I got a trinomial and a trinomial. Cool. Let's factor it. And I'm setting it up like this, of course, because they're both in the same form. Okay, what times what is negative 8, but when added together is 2? Positive 4, negative 2, absolutely, 100%. And what times what is 6? Positive 6, but when added together is negative 5. Negative 2 and negative 3, excellent. Thank you, gentlemen. Can I eliminate anything? The x plus 2, there is no x plus 2. Oh, there's an x minus 2, absolutely. So my answer will be x plus 4 over x minus 3. Does that make sense? All right, cool beans. Okay, next. Oh, this is a little different. Yes, sir. Okay, what happens if everything were to cancel? It'd be 1. The answer would be 1. Let's just say, just so everyone can understand what my boy's saying. Let's say I have this. And then for whatever reason, it factored out, and you didn't realize they were both exactly the same. Those would cancel, so it'd be 1. 1 over 1. Never 0, remember that. Because 5 divided by 5 is 1. Anything divided by itself is always 1. Thank you, that's a good question though, son. Okay, over here, my brothers. What can I factor out? And you do have a difference of squares. Thank you very much. Excellent. For the numerator. What do you want to factor out? A negative 4? I would. Because if I factor out a negative 4, I'm going to have now x minus 3. I just reversed it. It would have been negative 3 plus x, but I just wrote it as x plus x minus 3. Does everyone see what I did there? Okay, thank you guys. And then down here, difference of squares. Thank you so much. I'm proud of you. What would it be, my man? That's absolutely right. X plus 3, x minus 3. Because the difference of squares, remember, it's the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. Does that ring a bell at least to you guys? I know we've been gone for a couple weeks. But is that at least, oh yeah, okay, I remember doing that. At least there? Cool. May I continue, gentlemen? All right. Now, simplify, determine the values for which a rational expression is undefined. Okay. My brothers, what does it mean when I tell you something's undefined? When we're talking about a fraction or a ratio and I say it's undefined. Does anyone remember? Yes, sir. Try, just say it. Okay, it is impossible, but why? What lets you know that it's impossible, my man? No, you're thinking that. Thank you. Excellent. When something is being divided by 0, I'll give you both a high five because that was good. Good effort. Whenever the denominator is 0, that is called undefined. Remember, 0 divided by 5 equals 0 because 5 goes into 0 0 times. But 5 over 0 is undefined. 0 does not go into 5, ever. And don't say 0 times, sir. No, because 0 times 0 is 0, not 5. So whenever you have 0 in the denominator, it's undefined. This may seem commonplace to you right now, and it may seem like, what? So what? What does this do for anything? When we're starting to graph rational expressions, these are going to define your limits of your domain. Remember what domain is, guys? All the possible x values. This skill, I promise you, is what's going to allow you to determine your domain. So right now we're just learning how to identify what values would make this undefined. What values would make that denominator a 0? But just so you know where this is going, you know I like to do that. This is taking you to, okay, what are the limits of my domain? What is my domain? What possible x values can I use? Which values can I not use? So, since we want the denominator to be 0, just go ahead and set the denominator literally equal to 0. Okay? And then in this case, x will be -3. Now, most of you can do that in your head. I understand that. No worries. But again, later on, we're going to get more complicated and more complicated. And that's the concept of what I want you to use here. Set the denominator, regardless of how easy it is or how difficult, set the denominator to 0. You can do it in your head? Awesome. You can't? Solve it out. Is that fair enough? All right. So in this case, simplify and determine. Well, it's already simplified. Determine the values for which the rational expression is undefined. When x equals -3, it's undefined, right? So what do we say? X cannot equal -3. Because when x is -3, I have a 0 in the denominator. When I have a 0 in the denominator, that means that my expression here is undefined. And I cannot have that. So I can use any x value in the universe, any x value, no exaggeration, except for -3. Can I use 2.999999999? Yes. But I cannot use 3. Can I use 3.00000000001? Yes. But I cannot use 3. Does that make sense, guys? All right. So let's knock these out right quick. Simplify and determine the values for which a rational expression is undefined. Always, always, always factor, 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 factor. Simplify as much as you can, and then apply what they're asking you to your simplified expression. That's my suggestion. So I cannot simplify 5 anymore, any further so. However, what times what is -3, but when added together is -2? X minus 3 and x plus 1. Thank you. So now, do you guys remember the 0 product property? Remember that when A times B equals 0, then A equals 0 and or B can equal 0? So you have to set both of these to not equal 0. So which values cannot be used? Which values are going to give you an undefined value here? So x cannot equal 3 or -1. See? I'm not a stickler. I'm not going to make you do it out. But for anyone at home or in the class that's still kind of lost, what did this man do? Well, I want to know what value of x is going to give me 0 for x minus 3, and what value of x is going to give me 0 for x plus 1. When I solve those, these are the values that x cannot be. Because if x are these values, then you're going to have an undefined expression. Am I making sense here, right? Okay, let's move on. Thank you, guys. Okay, if we could just, there we go. Okay, 8x cannot simplify. What times what is -3, but when added together is +2? X plus 3, x minus 2, x minus 1 this time. So x cannot equal -3 or 1. Why can it not equal -3 or 1? Because it will make, either one of those x values will make the expression undefined. Excellent, son. Thank you. Great job. Okay, how about here? What can I factor out of the numerator here first? 7x. Very good. Leaving me with an x plus 2. Then down here I've got 49x. Well, guess what? I can cancel that x out. I can cancel out a 7. So I have x plus 2 over 7. Am I limited by anything in the denominator? Does x affect the denominator in any case here? Does it? So x can be any number, right? Yes. X can be all real numbers. No x value makes this expression undefined. There is no value that's going to make this undefined because the denominator has already been set for you. It's 7. Is this making sense, guys? I'm going slow because I know, we're all getting back in gear here. I don't want to bore you though, but I want to blow right through it. Does this make sense? Everyone's with me? Everyone understands the nuance here that there's a denominator that x has nothing to do with. So in this case, the domain is all real numbers. No x value will make this undefined. Does that make sense, guys? Cool. Thank you. I'm not trying. Yes, sir. Thank you. Oh, I'm sorry, son. This symbol right here, it's basically I do a parallel line and then I make a big R. It's all real numbers. And it's not made up by me. It's mathematical. Thank you, son. Great question. All right, guys, let's knock these out. Let's just simplify them, okay? Whoa, we got 4 terms here. Does anyone remember how to do these 4 termers? Thank you very much. Group them. Group them. What do I factor out of this first one? I take out an a squared. I'm left with a plus 3. Very good. What do I factor out of this guy? 2. So I'm left with a plus 3. So what does that numerator factor out to? A plus 3. Very good, because you took this guy and this guy, factored it out, and then my leftover is a squared plus 2. Excellent. Now, the denominator. What times what is 9, but when added together is 6, boys? Plus 3, plus 3. So this is a plus 3 over a plus 3. Get rid of one of them. Ding dong, the witch is gone. Bye-bye. A squared plus 2 over a plus 3. Guess what? You just simplified a pretty nasty rational expression. It's pretty good, guys. I can't tell you with all honesty that's the worst one, but pretty nasty. You had a grouper on the top. A lot of people don't even remember how to do the 4 terms, so I'm proud of you. Then you had pretty Mickey Mouse, but that's a perfect square trinomial. So, just these are decent ones. All right? Thank you for asking and caring. Just out of curiosity, what value can a not equal here? Very good. Why did they say -2? No. The numerator does not affect the denominator, does it? When I'm trying to find out the limits of x, okay, I'm only focusing on those that are in the denominator for right now. Does that make sense? Because does it matter? Can I have 0 in the numerator? Yeah. It just means that it's 0, so I can have 0. Can I have 0 in the denominator? So if they ever ask you, what are the limits of x, or what's the domain, or what value makes this undefined, you're only looking at the denominator. Is that clear, guys? Okay, cool. Next. This is a perfect square if you guys don't remember it. It's going to be, actually, no it's not. Add it to the cubic method. It's not a perfect square. All right, is it? No, I don't think so. 2x, 2x, so this is 4. What times what is 4, but when added together is 4? Huh? 2 and 2, yeah. So actually, yeah, it's x plus 1. That doesn't make sense.
Oh, wait, you made the 4x2.
Wait. Thank you, guys. 4x, sorry. And then I have 2 and a 2. Yeah, so it's 2x plus 1 squared. Yeah. Over now. What is this?
It is 2x plus 1,
2x plus 1, 2x minus 1. It's a difference of squares. So now, I can simplify. Don't I have two 2x plus 1s up here? And don't I have 1 down here? So get rid of this one, get rid of one of those. My answer is 2x plus 1 over 2x minus 1. Talk to me, sir. Okay. When I do an artificial factor, doesn't that become 2x plus 1? And then doesn't that become a 2x plus 1? So 2x plus 1 times 2x plus 1, it's like saying 2x plus 1 squared. You could have written them out individually if it makes more sense for you, my man. Thank you. Yes, sir. I cannot cancel out a 2x with a 2x. I cannot cancel out individual pieces of polynomials. And that's why I always repeat myself, and I guess I did not repeat myself enough. You cannot cancel out individual terms from a polynomial. Actually, it's a great question, my man, and thank you for asking that. If anyone else did that, good. That's how you learn. You cannot do that, okay? Just like here, you cannot get rid of these two. You cannot. You just can't. Don't do it, please. Okay, but we can group them. Okay, let's group this sucker. What is this first term factor out to, this guy over here? Yeah, y squared, and that leaves me with y plus 1. And what am I going to factor out of here, y'all? Absolutely negative 3, give me a y plus 1. So that's going to give me a y plus 1 times y squared minus 3. Now my denominator. What times what? Actually, let's just do it right here. What times what is negative 2? But when added together is negative 1. Negative 2 plus 1, absolutely. Y plus 1 cancels out exactly with y plus 1 because you can only cancel out exact polynomials. And you're left with an answer of y squared minus 3 over y minus 2. I am not being sarcastic or anything, so please don't take it like that. But you cannot now simplify this y and that y. You cannot. That's your answer. Does that make sense, y'all? Okay. Over here. Whenever you have something like this where it's 4 minus x squared, I'm going to give you a little hint, a little help. This factors out to be 2 minus x and then 2 plus x, but that's a little bit of a pain in the butt, in my opinion, because we're trained to see the x's in the front always. So if you wrote it with the x's in the front, it'd be negative x plus 2 and then x plus 2, which also looks a little weird because we've been trained to have a negative one, a positive one here. So to eliminate all of that, what I always teach my students to do is first factor out a negative from this. So now it would be x squared minus 4. Do you feel me, guys? And then can't you recognize a lot easier that's a difference of squares? So that means I have a negative times x plus 2 times x minus 2. Now I can factor the denominator, okay, which I'm going to have cubic method. So let's go 2x, 2x. That's negative 12. What times what is negative 12? What I add together is negative 1. Negative 4, positive 3. Very good. Take out a 2. So I got x minus 2 times 2x plus 3. So I got x minus 2 times 2x plus 3. Cancel out the x minus 2's because they're exact. And my answer is negative times x plus 2 over 2x plus 3. And just for giggles, what can x not equal? X cannot equal what here, guys? Negative 3 halves. Very good. Because you set the 2x plus 3 not equal to 0. X cannot equal negative 3 halves. Why? Because if it's negative 3 halves, the denominator will become 0, which is undefined. Does that make sense? All right, we're good. Thank you very much, guys. Great class. Hope you learned a lot. Have a great day. God bless you all.